Okay, section 1.6, part 1. We're going to talk about compound inequalities. Compound inequalities. Now, compound inequalities is where you have something on the left side, your variable in the middle, and something on the right side. We combine these two inequalities with the words and or. An and graph typically looks like this, where everything in between is the answer. Let's say this number was -2 and this number here was 0 and our x was in the middle. So our x would be less than or equal to 0, but our x would be greater than or equal to -2. So that would be an example of an and compound inequality. An or looks very similar to that, except they go in the opposite directions. So if we had this as our answer, we would write our x is less than or equal to -2, or our x is greater than or equal to 0. It has to be one or the other. Can't be both. So an example on how to solve these, we'll go example number 1. Let's say we had 13 is less than 2x plus 7, which is less than or equal to 17. Now there are two ways to do this. We could either split it up into two separate equations and solve them, or we can solve them as they lie, getting x all by itself in the middle. So I'm going to do method 2 first, where I'm just going to use this, and then over here I'm going to show you method 1. So this is keeping it together. So my goal is to get that x by itself. So the first thing I have to do is subtract 7. And I have to subtract 7 to both sides. Now since I just subtracted 7, there's no changing of my inequality signs, and I still have my 2x in the middle. On this side I have a 10, and on this side I have a 6. Now I still have to work to get x by itself, so I'm going to divide by 2, and I have to do it to both sides. So over here I have a 3. Notice my sign never changed because I never divided or multiplied by a negative number, and 10 divided by 2 is 5. So here I have my variable in between 3 and 5. The 5 side is a solid dot, following the rules from section 1.5. And the 3 is an open dot with my x in the middle. Now another way of doing this is I can split it up into two equations. I can take the left side and say 13 less than 2x plus 7. And then I can take the right side, which is 2x plus 7 is less than or equal to 17. And I can do them separately, graph them separately on the graph, and it'll turn out just like that. Do it really quick here. X is greater than 3. And x is less than or equal to 5. That ended up graphing as an and. Now we're going to do an example where we have an or. And when we have an or problem, we can't keep it together because it's either this or that. It can't be both. So So solving one of these, we just have to do it like two separate problems, like we did up here. So first I'm going to add 2 to both sides, and I have y is greater than -1. Or, subtract 4 to both sides, I have y is less than or equal to -7. When I graph that on a number line, I have my 0 over here, my -1, my -7, and y is greater than -1, so I have an open circle moving to the right, and my y is less than or equal to -7. Less than or equal to -7. So they're going in opposite directions.